Hey, in this video I'm going to do a build of one of the tools I did in the Digital Circuits Part 2 guide that I did on tools. This one is I call it a clock generator. Magic spot for the autofocus. I don't know. It's a clock generator. It uses a couple 555s. There we go. And it adjustables. So they're astable, multi-vibrators, 2 adjustments for the 2 resistors that define the timing of the circuit, and messy hand-wired prototype. Oh, there we go. That's nice. I have a nice little Osh Park board to put it on. So let's go to the bench and solder it up. All right, here we go. This board's a little smaller. Round 2 of the boards, version 2. I've made them all the same size, which will be nice when I go to make a 3D printed case. I just need to do one, and then they'll all fit in the same size case. So just tidying up here. One problem with this board is I didn't use the same part, or let's say for the variable resistor, I used one part. It's not the part I ended up getting, so they just sort of not quite fit right, but they do end up fitting. So it could be better, but it's not horrible. So let's see, we only have 2 resistors on here, and those are feeding the LEDs, or working with the LEDs. So we'll start with those since they're closest to the board. Both of the timing resistors are these variable resistors. So we have a couple of 220 220 ohm resistors, sort of generic current limiting resistor value for the LEDs, which seem to work okay. So again, we'll spread the pins on these to hold them in place, or the leads, not the pins really. And up here, use that later. And there we go. Trim the leads off. There. So those are the 2 resistors. Next up, I think I'll put these variable resistors on. If you notice, one of them doesn't quite fit. The pins themselves fit in the board not too badly, but they're just a little too close together. The bodies are a little wider. That was just sloppy board design work on my part. For version 2, I found the exact right fit part, so it worked a little better. So I got it to fit. It's not perfect, but it will work. With these, we'll do the trick of just dropping it. Just tacking one of the pins in, and then we can flip it over and properly solder everything in place. Okay, there's that. Yeah, these aren't perfect, but it'll stay in place well enough, I think. You can see in the end there, it's a little off. There we go. These pads are so tiny; they're almost vias. The other version of the board has bigger pads for the pots as well. So again, we'll pull these off. There. Stray solder bits. Okay, let's do the other ones. Okay, that. There we go. And there. As before, just get them tacked on. There we go. Now, I did hear from Osh Park that the machine that slices up the panel into individual boards messed up these a little bit, and you can see that around the edge. Those folks are pretty awesome, so they've sent out another set of boards just when they noticed that, so that's cool. But the boards themselves look fine, so I would have actually told them not to bother since these are first pass boards, but that's awesome customer service. You gotta like that. So next up, we will put the sockets in for the 555s. Again, taking note of the outline on the board, taking note of the notch in the socket, putting it in, making sure it's seated, bend down opposite corner pins. And I'll put the other one in now too, again keeping the notch aligned properly. There we go. And seating it well, bending down the opposite corner pins. There. And just soldering these on. Solder, solder, solder. So much soldering. Soldering brings joy to my days. It's a bit overstating it, but still, it's nice to be soldering a lot again. So now these capacitors I picked out for this do have the plus and minus marked on them, which makes it easier for electrolytics. So we just orient the minus side of the capacitor with the minus on the board. There we go. Same for the other one. This is the timing capacitor. Works in conjunction with the two adjustable resistors. So the two resistors together will define, in conjunction with the capacitor, the charge time of the cycle. So that is the amount of time that the output will be will be high per cycle. And then one of the pots will determine the discharge time. There we go. So that's that. Now let's do the LEDs. I picked a blue and a yellow. So again, we have the flat side of the LED, flat side on the board outline. Choose a blue and a yellow just for a little difference. Now, this board I have LEDs on the output to indicate. Basically, because the adjustments, you're going to adjust a pulse train, so essentially how fast it flashes and how, like what the duty cycle is, how long it's on versus how long it's off, although not quite that straightforwardly. So I figured I'd put LEDs on here so that you have some visual indication of the adjustments you're making, because it's not really going to be visible otherwise. Okay, now we have a 14-pin socket for an inverter. So if you notice here on the output, we have oscillator or clock generator 1, clock generator 2, and there's a positive and minus on both. I could have done a 2-row connector, which would have been like a 2x2. I didn't really like the aesthetics of that, so I put it in like a 1-row connector. And we have, plus minus, so active low, active high pulse trains for each oscillator. So again, we orient this socket to match the board, bend the pins down, solder it in. So because of the way that you make the adjustments, because of the way those resistors work, so both resistors determine how long the output's high, or what percentage of the time the output's high, and one resistor determines how long it's low, which means, like the charge and discharge times, that it's always going to be skewed one way. So your charge time, the output being high, is going to always be greater than the time the output's low and it's discharging, just because of the circuit. So, which means you can only ever get greater than 50% duty cycle. That makes sense, yeah. So with the inverter, and the plus and minus output means that you can basically flip that over and get less than a 50% duty cycle from that. So depending on what you need it, whether you wanted a string of sort of negative pulses or low pulses when it's generally high, or high pulses when it's generally low, you have that ability just by choosing which output you hook up to. So I thought that would be a useful feature as well. There we go. Now the LEDs only indicate one. I didn't think it was overly useful to show both because it's just a mirror. So here, let's just flip that over to make it easier to solder. Now that it's tacked down with one of them, there we go. Now, same deal as before for power. So the circuit's actually pretty simple. I mean, partly because there's only 2 copies of it on the board. I figured 2 is all you need in terms of generating pulse trains. So, as before, let's see which is plus and minus. Yeah, again, so this pin 14 of this inverter I see is power. And look at the trace on the board, that goes right up to here. And again, the final version of the board will have this labeled on the connector. Wait for it to solidify. Likewise with ground. Wait for it to solidify. Good. Now, again, we have heat shrink tubing and another piece thicker or wider, larger diameter piece for the actual end. And there we go. Now this, put that a bit there. Amazing stuff, this. There. So that's done. We need to pop the chips in. Again, orientation on the chip. Make sure it's all lined up. This pin's in. Nope. If you look close, you can see that pin got bent. So Means we need to pull that out. That happens occasionally, bit of a pain, but always make sure that when you're seating these chips that they seat in nicely without bent pins. Because if pin bends, doesn't make contact, doesn't work. There we go. That's better. Push that back now. 2 more chips, the 555s themselves. Orientation. There we go. 1 more. There. Let's test it out. Alright. I'm going to slide this over so you see the logic probe. Here we go. Let's see. Yeah. Turn it on. Yeah. Okay, so this one, plug it in, power the right way around. Actually, we do not need the logic probe for this because I put on those indicator LEDs. Oh, look at that. See, they're on for quite a bit of time and then they turn off briefly. So we can start adjusting. So the blue one, see, it's off more this time. Let's just put this down. Let's put this down the other way. Let's put this. So you see the blue one is just flickering off. Now this is adjusting. Oh, and it gets to the end, it doesn't work so well. You just back it off a bit. So that's flickering pretty quickly. And if we adjust this now, you can see it's pretty close to even, and then if we go here, it's on for a lot longer now. So they're not, it's not like one adjusts frequency and the other adjusts duty cycle. They're interdependent, so you play around with it to get what you want. So let's see this one here. Alright, so they're independent. We got indicators. Now, if we do pull up the logic probe, where did it go? No, it's a blank board. It's blank board. Here it is. No. Right. So if we plug in the logic probe, right? Yep. If we look at the outputs, this is number 2, positive going output. So we should be able to see. Right. Oh, here you go. And this is oscillator 2 over here, so it should coincide with the blue LED. Right. And that is indeed the +1. So now here, it should be the opposite, going green when that's high. This should go red when the yellow one's on. Or sorry, go green when the yellow one's on. This will go red when the yellow one's on. Alright, so there we are. Little continuous pulse generator board.